Foundations of Amateur Radio. Let me start completely off topic today with a thank you for emails and other expressions of concern regarding the demise of the bearing last week from my messy desk. I did not lose my marbles other than the ball bearings in the disposed item, and my sanity is as intact as it ever was. I'm also asked for photos of the messy desk, and as a concession to that, I'll use a photo of the ball bearing for the podcast edition this week. How am I able to produce a photo of the disposed ball bearing? Truth be told, it's in the bin. The bin is in my office, but it wasn't emptied last week since there was so little inside. So the ball bearing lives until Tuesday, when the bin will surely be emptied. Now, on to amateur radio matters, since that's why I'm here, though based on your emails I'm not quite yet sure why you're here. Yesterday, a good friend of mine, who tragically has yet to see the light and become a licensed amateur, came to me with a non-functioning antenna. He had purchased a so-called ground-independent monopole, suitable for 380 to 520 MHz. You get no points for guessing that this was to be used for a CB installation on his vehicle. When you read the accompanying material, this magical antenna has a 4 dB improvement when compared to a 3-wave whip in the centre of a metal roof. But then when you look at the footnote, it talks about a 4 dB improvement over a quarter-wave whip. But pattern tests only deliver a 2 to 2.5 dB actual gain. I can hear you groaning from here. It leads me to several observations. As a licensed amateur, you should be able to already spot holes as wide as a semi-trailer in those few statements. As amateurs, we're often dismissive of the CB community, but how can they be held to account if manufacturers publish what looks to me like drivel of the highest order? The design itself is curious. There appears to be a loading coil in the base. The centre of the coax is trimmed to a specified length and inserted through the coil. An electrical continuity exists between the radiating element and the coax shield. After spending some time troubleshooting the installation, I determined that the PL259 connector at the end wasn't actually soldered to the coax, so we fixed that. Using my antenna analyzer, we trimmed the vertical as specified, a couple of millimeters at a time, but it wasn't setting the world on fire with the updated SWR charts I was generating. We stopped trimming when we got close, since cutting off length is easy, cutting on length not so much. I then reread the instructions and queried the length of the trimmed bit of inner coax that was inserted into the loading coil, and found out that it was about a centimeter too long. Fingers crossed we trimmed that to length and the SWR chart improved. It still didn't set the world on fire, but at least the SWR wasn't 8 to 1 on CB channel 40. Of course, I've urged my friend to get an amateur license, but that's ultimately their own choice. What I took away from the experience is that even a very basic amateur license like the one I hold is sufficient to understand better what is going on and to be able to begin the process of troubleshooting antenna installations. I thought I understood that this antenna was basically a vertical dipole, but at the moment I'm not sure, and I'm wondering if the loading coil is actually a matching circuit, and I wonder why the coax shield and the radiator are connected to each other. I'm sure the antenna is designed with the best intentions, and I'm moderately confident that it works as intended. Now all we need to do is train the marketing department to talk to the engineering department before publishing their materials. For me, the takeaway is twofold. Don't blame a CBer for their lack of knowledge. Sometimes the manufacturer is to blame. The other takeaway is that with basic understanding of amateur radio, you can help your fellow radio operator. Now, where on my desk is that thing I was looking for? I'm Onno, Victor Kilo 6 Foxtrot Lima Alpha Bravo.